Welcome to Vision Plus and welcome to this senior for mathematics on complex numbers. We are now looking at properties of modulus of a complex number. And we are saying that if you are given two complex numbers, say Z1 and Z2, then the magnitude of Z1, Z2 is the same as the magnitude of Z1 times the magnitude of Z2. This expression that you are seeing here is just simply the magnitude of Z1 times the magnitude of Z2. It is a product of the magnitudes of the two complex numbers. And then if we are given the magnitude of Z1 over Z2, it is the same as getting the magnitude of Z1 alone, and then you divide it by the magnitude of Z2 alone. That is how you apply the properties of modulus. Now, there is an NB here that the magnitude of Z1 plus Z2 is not equal to the magnitude of Z1 plus the magnitude of Z2. That is true. This side is not equal to the other side. And also we are saying in Roman 2 that the magnitude of Z1 minus Z2 is not equal to the magnitude of Z1 plus the magnitude of Z2. What does it mean here? Let me simplify it. For the first part here, that is a Roman 1. This is the mathematical representation, but let me convert it into statements. This one means that this is the magnitude of the sum, or the modulus of the sum. Remember, modulus is the same as magnitude, is the same as the size or the length. So we are saying that the modulus of the sum, that side means modulus of sum, is not the same as the sum of modulus. Because here you are seeing that you're adding the modulus of Z1 to the modulus of Z2. So this is the sum plus this is the sum of the modulus. So we are saying the modulus of the sum is not the same as the sum of the modulus. Now, what then is the relation between the modulus of the sum and the sum of modulus? The relation is that for Roman 1, the relation between the modulus of the sum, which is the magnitude of Z1 plus Z2, is that the modulus of the sum is always less than or equal to the sum of the modulus. That means the magnitude of Z1 adding it to the magnitude of Z2. This is the relation between the modulus of the sum and the sum of the modulus, is that the modulus of the sum is always less than or equal to the sum of modulus. What is the implication? The implication here is that the modulus of the sum cannot exceed the sum of modulus. In other words, the modulus of sum cannot be bigger than the sum of modulus. It is either equal to it or less than it, but it cannot exceed the sum of modulus. So that is the relation of that. How about Roman 2? What is the mathematical interpretation of this? We are saying that this is the modulus of difference, because here it is minus. So we're going to say this is what? This is modulus of difference. And we are saying that the modulus of the difference is not equal to the difference of the modulus. Difference of modulus. That is, if you are given two complex numbers, if you find the magnitude of their difference, it is not the same as the difference of their magnitude. They are not the same. What then is the relation between the modulus of the difference and the difference of the modulus? The relation is, now Roman 2, the relation is that if you have the magnitude of Z1 minus Z2, this is the modulus of difference, it is always bigger than or equal to the difference of the modulus, which is Z1 minus the magnitude of Z2. We have said that the modulus of the difference is not equal to the difference of the modulus. And the relation is that the modulus of the difference is always bigger than or equal to the difference of the modulus. In other words, here we mean that the modulus of the difference will always be bigger than the difference of the modulus, or it will always, not in all cases, but at some point, if if the modulus of the difference is small, then it cannot be smaller than the difference of the modulus. That means the difference of the modulus is always less than the modulus of the difference. But in some cases they can be equal to, because if you look at this symbol, this inequality symbol, more than or equal to, it has two aspects in it. And this means that it can be more than or equal to. This is the interpretation maybe on the computer. So these are the facts that hold. Now, these two new concepts here, this and this, they fall under a concept that we are calling triangular inequality. Triangular inequality. Triangular inequality. And this concept is applied so much when we are looking at errors. There is a senior 3 topic called error approximation. And of this sort, we found something of this format. So now this is the overview of the properties of the modulus of a complex number. But we are not going to dwell so much. We shall not go so deep into this. What we shall always be applying are the first two options, A and B. These two are more advanced and they are out of context. We are not supposed to really handle them, but these are the facts that hold. So let us go to example 1 and we see how we can apply the properties of our modulus to solve given complex numbers. Thank you.